A number of you asked me for explanations on projectile motion, which I think a lot of you find very challenging. So before I get into the sums, let me quickly give you kind of a guide that I use to do these calculations. Okay, so when I have to solve a projectile sum, I always try to do it mostly along the following structure, and in all my explanations, I will do this as well. The first thing I do is write down x VVGT, okay, initial and final velocity. Then my second step is always to make sure that I choose a direction as positive, up or down, depending purely on my taste. The third step would be to fill in all the obvious information in the structure that I wrote down. That would be stuff like if they specify the initial velocity of an object or it ends with a velocity or whatever, I will fill that in. Then there's the more difficult information, the not so obvious information. Now, what do I mean by that? They will never give you in the sum, for instance, the value of g. You have to know that depending on the direction you chose as up or down, your value for g will either be plus 9,8 or minus 9,8. Another thing that you must know is if you have something that you throw up in the air, that moment that that projectile turns around, your top velocity will be 0. That is information that you know that they don't give you. And then when you throw something up in the air and you catch it on the same height, the velocity going up and the velocity coming down will be exactly the same. And then another thing that you often get, and we're going to address in this sum, is often information about one object, if there's two, is relevant to information of another object. And those are the not so obvious information that you need to figure out. Okay, once you've done that, you choose an equation of motion. Now, if you have interpreted all the information correctly, you will have your values for VF, V final, V initial, and so on. And you must choose an equation from these that are given in your exam guideline document, so you don't have to know them off by heart. Now, these equations have something special in common. If you look at the very first one, there's no value for x or for the displacement. In the second one, there's no value for time. And in the third one, you don't need a final velocity. And this information, together with the information that you're going to use to decide on which formula you need. Now look at this, for instance, this is now just a made up set of information. I said, I saw from my obvious and not so obvious information, I gathered what my displacement, my initial velocity, and my gravitational acceleration should be. In order to find an equation, you usually need you have three pieces of information, and they ask you for the fourth. But then there will be a piece of information which they neither say anything about or they request it. And that's how you know which equation you're going to be used. That piece of information, you look for the equation that does not contain that piece of information. In this case, it would be that one in this example. Obviously, if they gave you all the different pieces of information, just make sure that you didn't misread something or took a value for displacement of A and plugged it into B. Make sure you haven't done that. But sometimes they give you the value of everything, and then you can just go ahead and choose whichever equation you find the easiest. And then your last step, which is the easier one, is to plug in all that information into your equation and make sure that you apply the correct maths. And it is also very important that you remember your directions. As in my example, for instance, let's say I chose down is going positive. Then I know my value of G must be positive. If this ball is going down, this value must be positive. And I can see from the information, initially it was thrown up and then it came down again. Okay, so that is information on exactly the method I'm going to apply in the next couple of videos. Thank you very much.